Okay, what I'm going to try and do here is work through a what's called a multi-step um, reaction stoichiometry. And so, it turns out most of the reactions we've been looking at have been pretty simple, and in the real world, they're not always that simple. And so, in this particular case here, you can see that I got a three-step reaction happening, right? So this might be, whoops, this might be my first step. Why do you not want to give me that color? There we go. So let me erase you really quickly. So this is my first step here. Here's my second step here. Here's my third step here. And one of the things you might notice is that in the first step, I make this PO3. And the PO3, you guys, is a reactant in my second step. And then in the second step, I make this H2PO3, which is a reactant in my third step. And that's a really common way of chemical reactions occurring. So in step number one, you make something, and then you use that thing you made in step number one in step number two. In step number two, you make something, and you use one of the things you make in step number two and step number three. And it's a really, really common sort of series of events here. And so we're going to go ahead. Let me get you out of my way. We're going to use that to sort of figure out how this whole thing here is going to work. So what I'm going to do is balance this equation or set of equations out here really quickly. So I think I'm going to need, that's 5, so I think I'm going to need 2 of those, which means I'm going to need 4 of those. And 1 of those, does that look right? 4 phosphorus, 10, 12 oxygens, and that works. And then I'm going to do the same down here. It looks like I'm going to need 2 of those, and 1 of those, and 1 of those guys right there. And then that gives me Cl2, so I need 1 of those, so that's going to work out just fine. And then down here, I think I need a 2 there and a 2 there, and that might balance it. Let's see, 4, 2 is 6. Yeah, that's going to balance it. 2 phosphorus, 2 phosphorus. 6 plus 2 is 8 hydrogens, and 8 hydrogens. There we go. Now notice sitting over here, you guys, we have the percentage yield. So each one of these steps has a percentage yield. Typically, I like to write those on top of the arrow. So this is an 81%, right? Or a 0.81, if you will. This is a 0.72, and this is 44%. This is a 0.44. Okay, and those are going to come in handy as I finish this whole thing up here. Now, this says if I begin with 57 liters of this, and then the assumption here is that I have excess of everybody else that I need, and it's asking me how many grams of H3PO4 can be created. Well, how many grams of H3PO4 can be created if I start with 57 liters of P2O5? So the very first thing I want to do is turn that guy into moles. And so there's 22.4 liters of P2O5 to every 1 mole of P2O5. And now before I get too far along here, I kind of want to figure out my path. So I'm going to use a different color to kind of show you that. So it looks to me like down here I've got PO3, like I showed you a second ago, that's being made in the first step. So I think what I'm going to do stoichiometrically is come over to this guy and then bring those moles down here and then go from here over to here and then bring those moles down here and then go from here over to here. Okay, so I've just got a bunch of mole conversions to do here, but I can do those remarkably simply. So what I can't do is jump from moles. Here's what I cannot do. I cannot go from moles of P2O5 to moles of H3. Ooh, let me erase that really quick. You see what I'm talking about. Moles of H3PO4. Again, using another color to sort of highlight that. the P2O5 is right there, the H3PO4 is right there. They're not in the same equation, which means that those coefficients are not related to each other at all. The only coefficients that are related to each other are coefficients from the same exact equation. So what I'm going to have to do is follow this more circuitous path. I'm going to have to go from moles of P2O5 over here to moles of PO3, and then I can bring those down here. And then I can go from moles of PO3 to moles of H2PO3, and then I can bring those down here. And then I can go from moles of H2PO3 to H3PO4. Okay, that works because then those are all just comparing things that are in the same equation. So I want to get rid of this guy here. See if I can make my re-eraser work again. Sydney used to call it a re-eraser, which I thought makes more sense than an eraser. Okay, so I'm going to go from moles of P2O5 to moles of PO3. And so that's in the first equation, so that's a 2 to 4 ratio. So I'm going to say 4 of those to every 2 of those. Now, normally what we would do right here is change moles of PO3 into grams of PO3. And then if we brought those grams of PO3 down here, we'd have to change them right back into moles again. So I'm just going to leave them in moles, you guys. And I'm going to bring those moles, where's my other color? I'm going to bring those moles down here is what I'm going to do. And so I'm going to say for every 1 mole of PO3, using the second equation, there's 1 mole of H2PO3, right? So I just went from this guy to this guy in the same equation. And then I'm going to do the same thing I did up here just a second ago, use the same color. I'm going to take these moles and bring them down here. Why didn't you write? There we go. Okay, so yeah, what I'm going to do is go from moles of H2PO3 to moles of H3PO4. That uses this guy here and this guy here. That turns out to be a 2 moles of H2PO3 to 2 moles of H3PO4 ratio. And I'm not quite done yet, so I got to keep going. So this is just an extension of this guy here, right down here. Okay, and so what I really want is, what do I want, grams? Yeah, I want grams of H3PO4. I'm almost done. I want to say for every 1 mole of H3PO4, if I add up all that stuff to get the molar mass, I'll get 98 grams of H3PO4. Use that one a million times so I kind of know it by heart. And then we're not quite done, right? Because we're in grams, but man, we crossed over that first arrow left to right. We crossed over the second arrow left to right. We crossed over the third arrow left to right, which means we have to consider all 3 of those percentage yields. So to get to moles of PO3, I should have multiplied that by 0.81. I can do it now. And then I brought those moles down here to PO3 and moved them over to H2PO3. So I crossed over this arrow right here. So I have to consider that 0.72. So I'm going to consider that. Ooh, that's a 2. I want a 7 there. Yeah. 0.72. There we go. And then I brought those moles down here. And I took those moles across over this way. So I crossed over that arrow again, so I have to multiply by 0.44. And I could have done that up here, like when I was finding the moles. Like I could have done it right there for the 0.81. I could have done it right there for the 0.72, and I could have done it right there for the 0.44, but I just saved it till the end. That's practice that I got into a long time ago that I think works out really nicely. So now I'm just going to go ahead and do all this multiplication and dividing and see how much H3PO4 I'm going to make. So just multiplying along the top, 57 times, that's a 1. 4 times, that's another 1. 2 times 98 times. And then I've got these percentage yields, 0.81 times 0.72 times 0.44. And now I'm going to start dividing by what's on the bottom. That's a 1. I've got a 2 on the bottom, and I'm going to divide by that. There's another 2 on the bottom. I'm going to divide by that, and there's a 22.4 on the bottom. And so I do all that math, and I get just about 128 grams. 128 grams of H3PO4. Now, I was a bad Mr. Gainley, didn't cross off all my units here. Let's just make sure they all cross off. That crosses off. Moles of PO, that crosses off. That crosses off. That crosses off. And so I'm in grams of H3PO4, so I like my answer. So there you go. If you've got a multi-step reaction, you can just do it all in one big long stoichiometric factor label problem there, and you just can't use two different coefficients that are in two different equations. Okay, hopefully that'll help you with a couple of the problems in your homework packet.